Hello students, welcome to my online physics class. Today we will start a new topic and the topic is moving magnetic force on a current carried conductor placed in a magnetic field. To find out the expression for the force acting on this conductor which is placed in a magnetic field, an uniform magnetic field, and it is from the chapter moving charge and magnetism. So without further ado, let's start. First of all, we will consider a conductor having length L and it is placed in a uniform magnetic field B. So we know very well that electron always moves in a direction perpendicular, it is in a direction opposite to the electric field. Okay, electric field, let us suppose it is in the left direction, then the electron will move in the opposite direction, that is towards the right direction. So in that case, there is a term called drift velocity. So you remember the expression for the drift velocity? I think you know. The definition of drift velocity is that it is the average velocity of the free electron under the action of an electric field in the conductor, okay, but in the opposite direction of the electric field. So here in this case, let us suppose the drift velocity is v, and this v must be equal to minus dl by dt. What is dl? Here we have assumed a very small element dl, okay, and dl, it is actually in this direction, then the electron velocity is in the opposite direction, and that's why the drift velocity, okay, in the expression of this drift velocity I have put a negative sign over here. Okay, now next thing is that there are some assumptions. What is n? N is the number of free electrons per unit volume. It is a number, it is a density of the electrons per unit volume. So next it is area. We have assumed that a cross section of this rod or this conductor, okay, it is A. Okay, now let us try to find out the total charge inside this conductor dl. So dq must be equal to number of electrons into electronic charge, the charge on one electron. So the number of electrons will be equal to number density, that is n, into the volume. This elementary volume would be equal to simple area into length. Here the area is A and the length is dl, so it will be A into dl. Okay, we will use this expression later on. Now next is we try to find out the expression for the force. We know that Lorentz force actually it is the sum total of two forces, electrostatic forces, that is QE, and the second one is magnetic force, that is QV cross V. Okay, so here we will assume the magnetic force. The magnetic force, of course, for this small element will be very small, so here we assume that the force is also small, dFm. Okay, this is a small force, and this must be equal to q v cross b, like this. You remember, q v cross b. Really? Yeah, this one is. But the force as the charge on an electron is negative. Okay, so the force will be opposite to the flow of the movement, yes, of course, the force will be attractive one, and that's why a negative sign comes over here, because the charge is negative. Okay, so here we just put electronic charge and a negative sign over here. V is the drift velocity and B is the magnetic field. Now this negative sign, okay, this is actually a force for a single electron, but the number of electrons is how many? N into A into dl. Okay, all these are electrons. The number of electrons are very much. So the total charge is here this one, N into A into dl into E. So just putting this value, N into A into dl into E, and there is a negative sign, V cross B. But again, what is V? V is equal to minus dl by dt. So just put the value minus dl by dt. Again, see here, putting the value of minus dl by dt. This is the cross product over here. Now see, this dt, okay, take this dt outside, and there is a negative sign over here. This negative sign and this negative sign cancel out, and only positive signs remains over here. Okay. Now what is NADLE? See here, NADLE. This is dq. So removing all, we get only dq over here. Now again there is a term dt. Put it here. Again dl sign over here, cross b. Remember this expression dq by dt? It is something familiar. It is the flow of charge per unit time, and this is known as current. So put the value of here I dl cross b. So the expression for the magnetic force is simply I dl cross b. So like this you could read, you could actually find out the expression for the total force, and for that you have to integrate the expression. So integrating, we will get the net force, and integration sign will come over here, and this integration sign will be here.